we will proceed in tedious calculus examples. We are started tedious calculus example. There are many examples that looks really tedious. Anyway, if it looks really tedious, then we are here to tackle it. And we are in last video, we talked about the basic of differentiation. Differentiation is nothing but division. But only difference here is denominator is independent and numerator is dependent. If that is the case, then it falls in differentiation rather than division. Okay, so we understood what is differentiation. Please watch the previous video. What is integration? Integration is nothing but multiplication, simple multiplication. If you multiply y into x, that is multiplication, y into x. But if y is dependent upon x, then it becomes y dx. This becomes integration. Okay, so algebraic multiplication where 1 is independent, y into x is independent, x would vary independently, but y is dependent upon x. The value of y is dependent upon x. If that is the case, then y into x will get resolved into y dx. Someone say y dx. Actually, it is y into multiplication dx. Okay, actually it is y into x in pseudo term. Y into dx, y dx. Okay, now where x is even, dx means delta x, very small, tends to 0. Wrong. Okay, dx means delta x where delta x tends to 0. This is modern calculus, and this is what it is deviating people from. Everyone is imagining delta x tends to 0, delta y tends to 0, and let that. Nothing is there. Simple multiplication is integration. Y into x. If y is dependent upon x, then it is written as y dx, y into dx or y dx, simple y dx. Okay, d is placed there to symbolize it that it is integral calculus. Okay, it is not direct multiplication. That's it. D has nothing, delta x tends to 0 or delta y tends to 0. It has nothing to do with delta x tends to 0, delta y tends to 0. Okay, y into x. If x is x-axis and y is y-axis, y-axis means at every x there is a height. At every x there is a height. Every x there is a height. This height is called y at any point. If this height is independent of the x, means height is 4, then it is a straight line. Y into x will give area of the rectangle. But y is x square. Y is x square. If that is the case, y is x square, then at x equal to 0, y is 0. X equal to 1, y is 1. X equal to 2, y is 4. X equal to 3, y is 9. If someone is multiplying y into x, okay, then it will not be y into x directly, because if we multiply two items, we think about calculating area of a rectangle. Same thing. So if I multiply y into x where y is dependent upon x, that is y equal to x square, then x square into x is not actual multiplication. Actual multiplication is the area between x axis and y graph. Y graph is like this. Okay, so y graph is like this. This is origin and y graph is like this, x square. If that is the scenario, y graph is x square, then if I'm say y into x, immediately someone would say x means x axis, right? And y means y axis. Means you are calculating the area of a rectangle. Anyway, if someone is saying 2 into 3, it is as good as 3 is width and 2 is height. That is 6. Okay, that is 6. But area of a rectangle is not multiplication of two sides actually. Okay, why you are going for area of a rectangle? 2 into 3 is 6. No, 2 into 3. Now, I have learned that every multiplication, I'll calculate it through area only. Okay, 2 into 3. 2 into 3 is one rectangle. One side is 3, one side is 2. Take a square which has a width 1 and height 1 and now fit it into this. How many it will come? Okay, 3. If it is 3 into 4, the 12 square will come. The area is 12. That one. Okay, if someone is saying y into x, where y is dependent upon x, y is x square, then x square into x, how much it is? It is not a rectangle. You cannot directly multiply. Go with the area calculation for the exact multiplication. If this is x-axis and this is origin, then this is x square. If I say x square into x, this is y. X square means y. Okay, x square means y. So x square is the height everywhere. X square into x means underneath whatever is the area that we are trying to calculate. X square into x. This area is, now it falls in integral calculus. When someone is trying to calculate area between x-axis and y-axis, where y-axis is not constant, it is dependent upon x, that the area underneath it, that is the actual multiplication, is the integral calculus. X square dx, x to the power 3 by 3, that is the net area. Now, if it is up to a person what kind of real life example he is taking. Okay, consider that this graph is the velocity of someone. Someone is running at velocity x square, where x is time. So at time t, at any time x, his speed is x square. If time is 0, means he is not running at all. Speed is 0. If time is 1 minute, consider 1 minute. Time is 1. His speed is 1 meter per minute. If time is 10, then his speed is 10 meter per. Time is 10, then his speed is 10 square, 100 meter per minute. If time is 100 minute, then his speed is 10,000 meter per minute. That is his speed, x square. Then what is the x square into x? Speed into time. Means you are trying to calculate distance. How much distance that person has covered in 50 minutes or 10 minutes. 0 to 10 minutes, if someone is taking the stopwatch and at the 10 minute he is pressing the stopwatch stop, then see from the beginning to the end how much distance he has traveled. Distance is velocity into time. Velocity is x square, time is x, then x to the power 3, wrong. You're trying to calculate any multiplication in area of the graph. So if this is x square and this is x, then this is the area, that is x square dx, x to the power 3 by 3. That's my distance he has traveled. If if at the end of 1 minute how much distance he has traveled, at 0.1 minute, at that moment his speed is 1 meter per minute, but he has traveled x square by 3, 1 by 3 meter 1, because from the beginning it started from 0. At the end of 5 minutes, he traveled 5 to the power 3 by 3, that much kilometer. Okay, anyway, so this is called integration. Integration means if someone is trying to multiply two items and one item is dependent upon other, multiplication can be resolved through calculation of the area, where one item is y-axis, one item is x-axis. If you calculate the area, you get the multiplication. But if why we go for graph? Because graph gives better way when dependency is there. If height is dependent upon base, then multiplication, because multiplication we can get through graph also. So multiplication, if we try, then area will typically not the rectangle. It will be non-rectangle. And there we need integral. Please watch our primitive calculus video. Anyway, so that is the scenario for the integral calculus. Now we are in phase of calculating flux. Consider flux means If there is a velocity, if there is a liquid that is flowing, there is a liquid that is flowing and it is crossing one area, it is crossing one area, then how much volume of the liquid that is coming out of the area, velocity into area, that is meter cube of the liquid that is coming out per second from the area. Okay, anyway, so we are in deep into doing the integral calculus. If we are deep into doing the integral calculus, now consider there is an electrical charge kept at the center of this sphere. Okay, now, okay, I believe 1 minute I can spend. So there is flux. Flux means consider there is a liquid source. Liquid source, it is kept at the origin and it is oozing out liquid outside. Okay, at the velocity of something. When it is oozing out all around, it has velocity something. How much is the liquid that is coming out of the surface? How much is the liquid that is coming out of the surface? The velocity of the liquid dot product with the surface vector. That much is the volume of the liquid that is coming out. Now it is up to what is the velocity. Now it comes in vector. Velocity vector dot area vector is the net flux coming out of it. If I know in a closed, this is called closed surface. If I know in a closed surface, how much is the liquid that is coming out of it? Okay, if I know and if I know the volume, then I get the characteristic that is called flux density. If I know flux, how much flux is coming out, if I know the volume, flux by volume is called flux density. Flux density is calculated. Flux is meter cube per second and density and volume is meter cube. Meter cube per second by meter cube per second. There is no dimension here. Flux density means at center of this closed surface, a liquid is gushing out. What is the divergence of the liquid? How much liquid it is gushing out? That tendency is called flux density or divergence. Anyway, now we will not go into that matter because we are here to solve integration. If someone is giving the flux density, consider flux density is x square plus y square plus z square plus 3. That is the flux density. At any point, this is the flux density. This is something called divergence. Any point. Like if I say my divergence of the liquid, flux density of the liquid is x square plus y square plus z square plus 3 means at the origin 0, 0, 0, 3. At the origin, the net flux that is coming out at the oozing out at the origin is 3. Okay, if x, y, z equal to 2, comma 2, comma 2, then x square plus y square plus z square will become 15 plus 3, 15. At point 2, 2, 2, at that point, the liquid that is gushing out from a point that is called flux density is 15. It changes everywhere. This is called flux density. Flux density means everywhere this flux density is different. If that is the case, consider there is a sphere. There is a sphere, and this sphere is centered at the origin. Then how much is the flux coming out of it? If I know flux density, if flux density is 3, just 3, then flux that is coming out is flux density into the volume. Flux density is flux by volume. Flux, net liquid coming out is flux equal to flux density into the volume. If flux density is constant, then it is 3, that is 3 into volume, whatever it is. Now we are landing up into multiplying 2. Whenever you are dividing two items and denominator is independent and numerator is dependent, go by differentiation, even though it looks simple. Okay, if you are multiplying two items and one is independent and one is dependent, go with integral calculus, even though it is very simple. Even though it looks like very simple, but go with integral calculus. Integral calculus is superset of multiplication. Anyway, you will get the multiplication. Differentiation is superset of division. Similarly, vector is superset of algebra because it adds direction to it. That it does not change anything, it adds direction to it. Similarly, integral calculus is superset of multiplication. Okay, better multiplication is integration. Differentiation is superset of division. Better differentiation is differentiation. So if I say that if the net flux coming out, if someone does not understand flux density also, but if I say the net flux coming out from a surface is flux density into the volume. Flux density is 3 and volume of this sphere is 4 by 3 pi r cube. Consider radius is 1, then it is 4 by 3 pi into 3. 3 gone, 4 pi. 4 pi, 4 pi. Flux means meter cube per second. 4 pi meter cube per second. Liquid is gushing out of the surface. Okay, how you calculated flux density into volume? Flux density is 3. Volume is 4 by 3 pi r cube. Settle. Don't do like that. If you are multiplying any two items, then better go with integral calculus. Then integral calculus I apply only when there is one independent, there is one dependent. Volume is independent and density is dependent. This is what discussion we are pursuing. Volume is independent and density is dependent. Means volume means at what volume you are calculating. Volume is described by x, y, z. Okay, if I have two dimensions, then in the independent component is x-axis. If I have three dimensions, then independent component is xy plane. Z-axis is dependent on xy plane. If there is four dimensions, then independent component is volume and dependent component is density. If I take a cubical region, and one point is origin, just check inside a cubical region. Consider there is a alloy of iron, gold, and silver, and so many things. There is a alloy. It is not mixed inside the alloy. Alloy means someone has made a cubical shape where everywhere different metals are there. If someone takes a coordinate that is 2 comma 2 comma 2, there it hits nickel and density is different. Okay, if someone hits 1 comma 1 comma 1, he hits iron out there, their density is different. So at different coordinate, density is different. Density is dependent upon different x, y, z. If volume means x into y into z, means density is dependent upon volume. Make sense? So if I say the net flux coming out is flux density into the volume, people can think about weight also. If there can be density that is kg per meter cube, that is called density. Typical density, weight kg per meter cube. How much is the net weight of the cube? Okay, if density is constant, 3 kg per meter cube, and cubic cube is 1 meter cube, then net weight of the cube is 3 kg. How you calculate it? Density into volume is the net weight. Similarly, here if I am trying to calculate flux that is coming out, and formula is flux density into volume is the net flux coming out, then flux density is x square plus y square plus z square plus 3. It is variable, it is not constant. Then multiply by the volume. If flux density and volume, these are $1 trillion explanation, you will not get anywhere else. Primitive calculus is like it is obsolete now. People go with delta x, delta y, delta z tends to 0 and they start fighting their head unnecessarily, not required. Anyway, so flux density into volume, we are trying to multiply two items purely, flux density and the volume. Volume is independent, flux density is dependent. It comes in a form of y into x, if you remember, two dimensions, where x-axis is there, y-axis is there. Y into x, when y is dependent upon x, it becomes y dx, or function over x dx. Similarly, it will become here density into dv, not v, volume. Density or function over x, y, z, or function over volume, f, function over v, that is density into d into v, where integration is from one limit to other limit. Okay, what is one limit to other limit? A person is walking at x square speed. At the origin, his speed is 0. At 10, his speed is 100 meter per minute, x square. How much person has traveled from when x is time, time between 2.5 minutes to time 4.1 minute. Point 1, point 1 is point 1 is really point 1 in decimal. So someone has to convert if he's taking second kind of feature. That is 60 second is 1 minute. He has to convert in decimal, whatever it is. The time is 2.5 minutes to 4.1 minutes. During this period, how much distance he has traveled? If this is x-axis and this is y-axis, that is x square, from one point, that is this is the speed at that moment, up. Okay, at any moment, no, this is the speed x square. At any moment, 2.5 times this is the speed, 4.1 times this is the speed. If I multiply the height by width, I get the distance. Velocity into time is distance. Okay, but here velocity d of x is what we are, because multiplication we are calculating the area. In that sense, from time now, if I do integration, it asks for lower limit and higher limit. Lower limit is x equal to 2.5 and higher limit is x equal to 4.1. That much distance he is covered. This is called one section is there. Anyway, it is very simple. Or it is same as that someone is traveling from 0 to 4.1 minus 0 to 2.5. That is the limit. Okay, and this whatever it is. Anyway, now this is understandable. Anyway, now if I am saying density into d of volume is the net flux, then volume density is function over volume. This is the big research that is awaited now. Can I consider volume as independent component? Actually, people consider x, y, z as independent component. Altogether, volume can I consider as independent component. Volume can I consider as an independent component. If I consider their function over V, volume into d of V, limit is volume, lower limit of the volume to higher limit of the volume. The way we did fx dx, lower x to higher x. Similarly, f of v dv, volume, lower limit to higher limit. Okay, so that is the net integration. Density function is x square plus y square plus z square plus 3 d of v. How you make volume? In Cartesian coordinate, volume is nothing but x-axis into y-axis into z-axis. If someone multiply all coordinates, three Cartesian coordinates, it becomes volume x into y into z. If it was only x-axis, then we said dx. Now it is d of x, y, z. Or we can write dx, dy, dz. Since these are at 90 degree to each other, dx, dy, dz, x square plus y square plus z square plus 3 dx, dy, dz, or d of x, y, z cube. Why d? Because it is integral calculus. It is not delta. It is not delta. D of x, y, z cube. If it was 3 dimension, then d of xy plane. It was 2 dimension, then d of x axis. Okay, d of xy cube. Volume 1 to volume 2. D of xyz cube is nothing but x axis, y axis, z axis. I can directly multiply these three. Then it becomes dx, dy, dz. Okay, if that is the scenario, it is matter of how we write. It's not that dx, dy, dz is multiplication of dx, dy, dz. Anyway, volume 1 to volume 2 means lower limit to higher limit. Now it will resolve into triple integration, where if we are trying to calculate through the flux that is coming out of it, now people can consider the flux density as real density. Then real density that is kg per meter cube is x square plus y square plus z square plus 3. I could have taken that example. The density of a cube, there is a sphere. Inside the sphere, it has different density. And density is x square plus y square plus z square plus 3. At what point, how much is the density? What is the weight of the cube? That is density into the volume. Volume is dV, that is dx, dy, dz. Now, v lower limit to higher limit. Now, lower limit of it resolves into triple integration x, y, and z. Lower limit of x, okay, let's go step by step. I believe that is better. D of volume is, or volume is nothing but this, if this is xy plane and this is z axis, multiplication of z with the xy plane, that is the volume. So that becomes dz dxy plane. Z dz dxy plane. What is formula of a sphere? That is a square, x square plus y square plus z square equal to a square. Z equal to square root of a square minus x square minus y square. That is z. So if I see the lower limit and higher limit of the z, the lower limit is minus square root of a square minus x square minus y square. Higher limit is plus square root of a square minus x square minus y square. That is the higher limit. So dz, integration of dz, and here it is x square plus y square plus z square plus 3. The net integration would become x square z plus y square z plus z to the power 3 by 3 plus 3z. And lower and higher limit. Lower limit is square root of a square minus x square minus y square minus to plus square root of a square minus x square minus y square. Someone can settle it down. Okay, if settle it down, it becomes a square root of a square minus x square minus y square into x square plus y square plus 3 plus x square a square minus x square minus y square to the power 3 by 2 divided by 3. That is the net integration. Then what remains is d of xy plane. D of xy plane. If I have to find d of xy plane, since xy are orthogonal to each other, it will resolve in dx dy. But since we have taken d of xy plane, if this is the ball and it is centered at the origin, this is the xy plane at the middle, it is cutting it. What is x and y limit? X and y limit, to know the x and y limit, then you have to see from the top and see the on xy plane what it is forming. On xy plane, someone sees from the top, it is making a circular region where x is minus a to a and y, the circular region. The equation of circular region is x square plus y square equal to a square. That is the radius of the sphere. Y equal to square root of a square minus x square. Now the limit, if I now break the dxy plane into dx dy, now the limit will be x and y. Y is minus square root of a square minus x square to square root of a square minus x square, and x is minus a to a. Now it's time to integrate with the y. So we got it a square root of a square minus x square minus y square in braces x square plus y square plus 3. Okay, and then a square root of, a square minus x square minus y square to the power 3 by 2 divided by 3. That much. Now someone has to integrate with it to y. It will become very, very complex. And then against y, you substitute lower limit is minus square root of a square minus x square to square root of a square minus x. Whatever comes, again integrate with dx. And then in x now place minus a to a. That will be the net weight of the net flux coming out of a sphere, or when the density is x square plus y square plus z square plus 3. I believe it is understandable. Now anyone will say, keep mercy on us. We cannot calculate this much. Can we do in better way? Can we do in a better way? Okay, we will try in different way. What if I integrate with dz? What came here? That is z square, z in braces x square plus y square plus 3 z into that much into 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 z to the power 3 by 3. That came as a result. Now square root of x square minus a square minus and that much and then dxy plane dx dy. Okay, consider the x equal to r cos theta. I can take method of substitution and integration and y equal to r sine theta. One is r cos theta and one is r sine theta. If that is the case, then the dx dy dx dy, this is what we are talking. Okay, then I can we replace dx as d of r cos theta and dy as d of r sine theta? No, because actually it is not dx into dy, it is d of xy plane. Actually it is d of xy plane. So it is complex. We cannot, we just wrote at a shorthand dx dy. Actually it is d of xy plane. It becomes dx dy when x, we took Cartesian coordinate system because x-axis and y-axis are orthogonal to each other. D of xy plane can be written as dx dy. But theta, r cos theta and r sin theta, they are not orthogonal or something like that. In that case, I cannot write dx dy as d of r cos theta and d of r sin theta multiplied. Not that way. Okay, if that is the case, then how we can solve? We can use method of substitution only for y. Consider y equal to square root of a square minus x square cos theta. Now I can substitute y equal to square root of a square minus x square minus sine theta d theta. That is possible now. Then it will become a square root of a square minus x square minus y square. Square root of a square minus x square will come out and it will become 1 minus cos square theta square root sine theta. Square root of a square minus x square sine theta. Okay, sine theta. It will become like that. And in braces, we have x square plus y square plus 3. Y square will become a square minus x square cos theta plus 3. And then plus z to the power 3. Again, it is very, very deep. Then someone would say that can you do something better? Then in something better, then probably we can use a spherical coordinate system altogether, a spherical coordinate system. Or I have to convert d of xy plane into d theta r, then it's possible. If I use x equal to r cos theta, y equal to r sine theta, then d of xy plane, how I can rewrite as d of theta r, considering theta r are orthogonal component, how I can convert it. There is something called Jacobian comes into the picture, that we'll talk later. Consider dx dy becomes r d theta dr. If someone converts it, r d theta dr, this is how it becomes. If you take direct multiplication, x equal to r cos theta, dx equal to r minus sine theta d theta, y equal to r sine theta, then r cos theta d theta. If you multiply dx dx dy, one you differentiate with theta, one you differentiate with r, it will become nonsense. Okay, dxy plane into d theta r plane becomes r d theta dr. How it becomes? Dxy plane can be written as dxy by d theta r into d theta r. What is dxy plane by d theta r? That is Jacobian. Anyway, it comes as r d theta dr. Now someone can solve it. Now outside is a square minus x square minus y square. It comes as a square minus r square. And inside is x square plus y square plus 3. X square plus y square becomes r square. Okay, it becomes r square plus 3. It settled down as a square root of a square minus r square into in braces r square plus 3. Okay, still it is all right. I believe so. Okay, and then z to the power 3 by 3. z to the power 3. That becomes a square minus r square to the power 3 by 2 by 3. Okay, this is how it resolves. And then r d theta dr. If someone proceeds in it, then it becomes a square root of a square minus r square, and then r to the power 3 plus 3r. Okay, and then r into r a square minus r square to the power 3 by 2 divided by 3. Someone can try it. There is no harm in trying, but still it is better. Okay, so this is Jacobian. This is how we try to settle down in a Jacobian format. Can we do better? Okay, then can we use a spherical coordinate system? In that sense, x will be r sine phi cos theta, y will be r sine phi sine theta, z will be r cos phi. Okay, then all together we have to start with different concept. I believe it will take a lot of time. Anyway, so we started with multiplication is integral calculus, and then if it is integral calculus, then two operand of multiplication, one becomes dependent and one is independent. Then dependent into d of independent we write. Then flux density that is function over volume into d of volume. D of volume we broke into d of xyz cube, or dz into d of xy plane, or then dx dy. Similarly, we broke the limit and then we tried computing it, failed because it is very complex. Then we tried polar coordinate system, it failed. Then we tried Jacobian, it failed. We'll try, but concept is same. Multiplication of two items is integral calculus. Rather than starting with the Cartesian coordinate and converting here and there, we will start with the spherical coordinates, and then we'll see that it is solvable or not. But concept is same. So that we will proceed upon. Don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code. We will see again.